8.2 insertion operation. Based on our analysis in 8.1, we know in order to solve that sorting problem, although it's an old problem, but we use a new way to solve it. The key is the insertion operation. So in this video, we will study the basic insertion operation. All right, so let's continue our discussion. So we saw this diagram in the previous video. Now we want to look at the details of this insertion operation, based on our intuition. First, in order to complete the insertion operation, we need two steps. The first step, find the right position for the new element. The new element A1, it should be in somewhere, the right place in the current or current sorted array. But which position? So we need to find that position first. So that is the step one. Step two, move elements. We need to give some room for the new element, right? In the current existing sorted array, there is no room. There is no room. So we need to shift some of the elements to the right, to the right hand side, shifting some of the elements to the, moving to the right hand side by one position to the right. Then we will have a vacant location for the new element. So that is the second step. Move elements to make array. Move elements to give a room to give a new location for the new element. Then make the array sorted. So that's the whole story. All right. So with this understanding, so now let's look at the implementation details. First question, how to find the correct position for the new element? By intuition, we can find it easily. How to find it? So the first question, here from this diagram you can see it should be somewhere in the array. The old array is sorted. Now you need to put a new element somewhere in the array. That is a search operation, right? So that is a search operation. Okay. Now you need to do search operation in the sorted array. How to do it? So here I just put a question there. Later we will look at the answer. All right. Next, how to move the elements to make new array sorted. Shifting operation. All right. Next, now we may like to look at the performance or efficiency. How many comparisons or how many operations do we need? Here, use some asymptotic notation. We can use big theta of k. K, the number of elements in a sorted array, k elements. So we can say on average, the number of comparisons or number of shifting operations. Two operations we need to do. Both. Each one, both big theta of k. Okay, yeah. But here I may like to ask you a little more. Yeah. What is the average case efficiency? What is the average case efficiency? Yeah. Here, what I'm asking you, exact. Yeah. Not using asymptotic notation, using the precise formula. What is the average case efficiency? Okay. Yeah. First, just guess, is this k over 2 average case efficiency? Yeah. Yeah. I want to say this one is close, but not exact. So this one is pretty close. Okay. Yeah. But if we want to get exact expression, how to do it? Think about that. Yeah. So I leave this as another question. Yeah. Later we need to answer it. Yeah. All right. Next, shift elements for insertion. Yeah. How to shift elements to the right to leave some room for the new element. Pretty straightforward. Yeah. Here I just use a simple diagram to explain that procedure. Yeah. All right, suppose AK should be inserted in, let's say in this location, okay? AK should be inserted in this location. Yeah. Now it is occupied by AI plus 1. Now, so we need to shift all the elements starting from AI plus 1 position to the right, one by one, every time one to its right position. And at the end, we get a vacant location at this position. Then we put AK there. Yeah. So that's the whole story. Yeah. All right, so now let's do it. Before we make the first shifting operation, we get a empty location right after AK minus 1. Yeah. So this is empty. Okay. Yeah. Next, now we do shifting operation one by one. Okay. All right. First, the element that was here before, we move it to the temporary location. So this is a temporary location. Then A sub K minus 1 position to its right, and so on. Each one position to its right, and so on, until we reach this destination location, this one. Okay. Now we are ready. After we make this location available for the new element, the last insertion, last assignment, element assignment, we do that copy, and then we make the new array sorted. All right, so that's the whole story. So here, the shifting operations, what you see here, the shifting operations, we have to do this much work. Yeah. So this much work, yeah, we have to do, everything here. Yeah. It's very hard to save anything. Can you imagine we can save a little bit? We cannot. Okay, all right. Yeah. But, so the reason I ask you if we can save some operation or not, the reason I ask you, I mentioned this question here is because in the search step, we can save some operations in the search step. Search. Look at the search step. How do we do the search? Search the right position. How do we do it? How do we do the search operation. Regarding the search step, there are two ways to do it. The first way, linear search. The second way, the binary search. We haven't learned binary search in this class. We will, later soon, we will learn the binary search because it is very important. But I believe all of you know binary search. So here I just use that idea a little bit, the binary search. Okay? To find the right position, it's possible to use binary search to get to the right location faster, right? The faster. All right. Faster than the linear search. Yeah. All right. But because this step we cannot save. So this step we cannot save. So that means even you can save in the search part, but you still need to do the same amount of work here. Okay? Yeah. So that will make your performance improvement very limited. Okay? Yeah. So here I talk about this issue because later in the last video of this part, the last video 8.4, I will talk about this issue another time. Yeah, another time, because it will give us some interesting idea to solve some special problems. Yeah. So in 8.4, we will discuss this another time. Yeah. All right, so let us finish our 8.2 right here.